We're going to look at some of the environments of deposition that are related to sediments. This first one is an evolution of a fringing reef to a barrier reef to an atoll reef. In figure A, there is an island mass that has a fringing reef. That is a reef that is right next to the island. As sea level rises, that reef is going to grow to keep up with sea level. So the reef, it goes straight up, and then the island in the middle is going to become more isolated, so that now the fringing reef becomes a barrier reef. Over time, as sea level continues to rise and that island erodes, now the island may disappear below sea level, and we're left with what's called an atoll reef, that is a ring of reef mound. So it looks like something like this. And these are found dotted around the South Pacific. Another thing to consider when we're looking at where sediments occur in the ocean is the mid-ocean ridges. So mid-ocean ridges are outlined in gray, and those represent the complex that would be perhaps some of that exposed basalt on the seafloor that is starting to have an accumulation of clays on top of it. But it is going to be a topographic high. The axis of these are noted by the yellow lines. So this whole area is the Mid-Atlantic Ridge, that mountain chain that is in the middle of the ocean basins, but just the axis there is where there's going to be earthquakes and volcanic activity. Along those same lines, so those were topographic highs, we're going to have pretty extreme topographic lows. And these are the ocean trenches that mark the location where oceanic crust is getting subducted. So the very long section here in the North Pacific, and then shorter segments down here towards New Zealand, and then over here the Middle America Trench and the Peru-Chile Trench with the subduction of the Nazca and the Coast plates. So that you got to remember when you're looking at seafloor sediments, what's going on with the seafloor topography in that region. So here are some of the seafloor sediments, and they're color coded. We'll start over here on the left with ice rafted. That literally means that these are sediments that are carried into the ocean, perhaps on icebergs, and then as those icebergs melt, the sediments are going to fall to the seafloor. Carbonate sediments in yellow, those are sediments that accumulate because of biological activity or because of the high concentration of calcium carbonate in the ocean. Siliceous sediments also can happen because of biological activity. Siliceous organisms have hard parts that are made out of SiO2, whereas the carbonate-based organisms are CaCO3. Red clays, these are oxidized clays that have blown off of the mostly out of desert regions. Siliceous / red clays, these also may have an origin in the deserts of the world. And terrigenous, these are in orange. Notice they are at the mouths of large rivers. So here off the coast of India, in the Middle East, all along the edge of eastern North America, and then in the Pacific Northwest here of North America. So these are all sediments that are derived from the land and have made their way down onto broad continental shelves. Why do we study marine sediments? The first three are just kind of about science, right? So we're providing information about the earth, what are the systems that produce these sediments, and these sediments occur over really long time scales. So how do those systems change or look over long time scales? They also can give us information about climate change, not only climate change that's happening right now, but climate change throughout deep time. So as sea level rises and falls, as those icebergs change the nature of the Arctic environments, we can really figure out a lot from ocean sediments about climate change. We also can use it to look at habitats and organisms and evolution of organisms over time, and about any impact we might have on those organisms. Seafloor sediments are also a source of minerals that we use in industry. There also is a whole science of looking at offshore pollution that involves the marine sediments. And then we can identify sites for coastal structures and perhaps a placement of oil platforms. So lots of reasons to study marine sediments.